Good morning, everyone. I welcome you back to my YouTube channel, and presenting before this tutorial is Hampiot Kliman. And if you are new to this channel, consider subscribing, and if this video helps you and your work, make sure that you share also to others so that they may benefit. So these are the courses that we teach: chemistry, physics, mathematics, biology, and please don't forget to subscribe. Let's get started. What is dimensional analysis? So dimensional analysis is simply a denotion of the physical nature of different quantities under physics. Okay, so under this topic there are certain symbols that we use that help us in order to prove if a particular formula is rigid. So I may just say that by definition, I may say that dimensional analysis is a denotion of the physical let me just write the correct spelling for physical. Okay, let me just say the notion of the physical nature of, let me just say, different quantities. Now, there are certain symbols that we use under this topic that are going to help us prove different formulas. So now, let me just write symbols used under this topic. Now, look at this. It's very important to understand that, number one, the dimensions of length are simply denoted by the letter L. The dimensions of mass are denoted by the letter M. Take note, the dimensions of time are denoted by the big letter T. Okay, so all these dimensions can be treated as algebraic expressions. What do I mean when I say algebraic expressions? By algebraic expressions, what I mean is I'm able to calculate them by inserting them into one another so that we may prove if a particular formula exists or is legit. Okay, so let's try to do some example. All right, so how about if they say write down the dimensions, write down the dimensions of the following quantities. Let's say I've been given these different quantities. Okay, let's say they say length. What are the dimensions of length? What are the dimensions of length? So if you want to try out, you can pause this video and then write down the dimensions of length. Let me just change the marker. The dimensions of length are simply big letter L. Okay, like that. Okay. So make sure you take note. The dimensions of length is simply L. Get to B. What are the dimensions of acceleration? Okay, what are the dimensions of acceleration? The dimensions of acceleration is simply L over t power 2. How do I come up with this? Remember that the units for acceleration is meters per second squared. Meters denotes the length. Seconds denotes the time. And the dimensions for length is simply L. The dimensions for time is simply big letter T. Therefore, while there is meters, I can replace with L. While there is seconds, I can replace with T to the power 2. Therefore, that is why we are writing as L over T power 2. Take note of that. How about the dimensions of displacement? Displacement under physics is simply some distance. So it is represented by the letter x. Therefore, its dimensions is simply letter L. Not much different from how we're supposed to write it. Very, very simple. Now, how about, for example, let's try to do some example. How about if you are given a question where they say, prove if the following formula is dimensionally correct. They want us to prove if it is dimensionally correct. How do we go about it? Let's say the formula given is simply V equal to VO or V initial plus AT. How do we prove that this particular formula is rigid or it's dimensionally correct? Let me just write the solution. Now look at this. For us to prove that this formula is dimensionally correct, what is on the right and what is on the left must be able to hold. It must be the same. So what I'm going to do is this. It's very simple. So we have V equal to V initial plus AT. Now the dimensions of V, velocity is simply meters per second, right? Now look at this. Meters is length, and length has the dimensions of L. S is second, which is time. So the dimensions of time is big letter T. Therefore, the dimensions of velocity is simply L over T. Take note of that. Okay? Same as V initial. It will also have the same dimensions. Now, let's come up with the dimensions of acceleration. I think we did that. The dimensions of acceleration is simply L over T power 2. The dimensions of time is simply big letter T. So now I can do my calculations. Let me just try to get a new column. Now look at this. Where there is V final, I am going to replace it with its dimensions, which is L over T. equal to, where there is V initial, I will replace it with its dimensions, which is L over T, plus where there is A, which is the acceleration, I'm going to replace it with its dimensions, which is simply L over T power 2. Where there is, now A and T are multiplying, so I'm going to multiply this and then I'm going to put my time here. Notice what is going to happen. This T and that T is going to cancel, so I'm going to have L over T equal to L over T plus L over T. Now notice this is good because what we have here is also here, it is also here. Therefore, this is dimensionally correct. Very simple. So that's it for this particular part. Let's try to do something else. Okay, how about, for example, if you are given this formula, they say okay, how about if you're given, let's say let me try to look for something else. How about if you're given V squared plus V squared. Okay, let me try to write like this. Okay. So this is V squared is equal to U squared plus 2AX. Let's try to prove if this formula is correct. It's dimensionally correct. What is the main essence of dimensional analysis? It is simply to prove if a particular formula that you're using is legit, if it's correct. There are certain formulas that you used to use in secondary school which might not be correct to use in university. Okay, let's try out this one. I'm going to use a different color. So the dimensions of V, we already stated, it is L over T. And of course, this is power 2. The dimensions of U is simply L over T, and of course, everything to the power 2. Plus, this is, now under dimensional analysis, we do not consider constants. So we won't write the 2. Okay? We don't consider constants. We only consider letters. So in this case, where there is air acceleration, we know that the dimensions is simply like that. Then everything multiplied by L, which is x. So what is going to happen is this. Look at this. L over T to the power 2 is going to be L to the power 2 over T to the power 2 equal to, this is going to be L to the power 2 over T to the power 2 plus, this is going to be L multiplied by L, it's L to the power 2 over T power 2. Have you seen? This is correct. So we therefore state that this formula is, dimensionally correct. Dimensionally correct. So that is the essence. You can try to use this concept under everything and you'll see that it will be able to give you the correct formula. Let's try to do some work, some more work. So you can use this, it will give you, okay? Let me give you this work. They say prove that the period of a pendulum given by the formula. What is the formula? The formula is t equal to 2 pi square root of some length over some g is dimensionally correct. So we just want to prove if this formula is able to hold. Let's try to do some solution. We shall use the same concept. What are the dimensions of t? T is the period, that is time. So the dimensions of t will still be t. Now remember I said that constants are not added under dimension analysis. We shall remove that. The dimensions of L is simply L. G is simply the acceleration due to gravity. So its dimensions are going to be L over t power 2, just like acceleration. Notice that where there is t, we can put t like that as its dimension equal to, we are going to give the square root of what is L. L is going to stand as L, which is the length. What are the dimensions of G? It is L over G. Sorry about that. It's L over t power 2, like that. Notice that we can do our calculations. This can also be written as L over 1, then t over L power 2. Sorry, this is going to be power 2, then this is going to be just L. That and that can cancel. So we're going to have t equal to root of t power 2. That and that will go. So we're going to have t equal to t. On the right, we have t. On the left, we have t. Therefore, we say this formula is dimensionally correct. Wow. Do you see what's happening? We are proving formulas in physics whether they are correct or they are not. So it just helps you to really understand what's really happening. Very, very simple. How about, for example, if we have been given this formula, and I'll take this to be my B. They say, prove that V equal to V initial plus AT is dimensionally correct. What are the dimensions of V? It is simply L over T equal to the dimensions of V initial is L over T plus what are the dimensions of acceleration? It is L over T power 2. What are the dimensions of time? It is simply T power 2. So that and that will cancel. We are going to have L over T equal to L over T plus L. Now look at this. We don't have a T in the denominator under L. Therefore, we say that this formula is not dimensionally correct. Not dimensionally correct. You see? Very, very dimensionally incorrect. Let's try to do another one. There are so many formulas that you can apply. MA is equal to V power 2. Mass has the dimensions of M. A is simply L over T squared. V is L over T. I can put my mass where there is M being multiplied by L over T to the power 2. The dimensions of V power 2 is simply L over T to the power 2. Notice that we don't have mass on the right hand side. Left, right. This formula is also dimensionally incorrect. The key to this topic is simply to know the dimensions of different quantities that you are given. All right. Let me just try to wrap the board. It's very simple. Very, very simple. Let's try some complex one, which happens to be the simplest, but a little bit complex. How about if you have been given this formula? Let me try to call it C. We find the dimensions of 1/2 mv squared equal to 1/2 mo. This is simply some velocity at some initial point. Square root of mgh, which happens to be the gravitational field force. Now look at this. Constants are not added under this topic, so we shall remove this. We are going to remain with mv power 2 equal to mvo power 2 plus the root of mgh. We don't add constants. What are the dimensions of mass? The dimensions of mass is simply big letter M. The dimensions of velocity is simply L/T power 2. The dimensions of mass is simply big letter M. And of course, the same thing is going to repeat. Notice that in the square root, the dimensions of mass is big letter M. The dimensions of some gravity is simply L/T power 2. The dimensions of height, it is simply L. So we are going to have something like this if we expand. And of course we have that is quite too far. Let me just try to wrap this. Thank you. So this is going to be L/T power 2 plus. Now look at this. This L and that L will multiply. And of course we're going to have something like L squared over T squared. Now look at this. M is multiplying L/T. This M is also multiplying L/T. Now look at this. These two and these two cancel with the square root. So the square root is going to remain with the M, but L/T will be outside. If you check, it's very different from the left and the right. This formula is therefore dimensionally incorrect. So this is how simple dimensional analysis is. It's very simple. All you have to do is to simply know the dimensions of different quantities. You are able to prove any formula that you are given, whether it's dimensionally correct or dimensionally incorrect. If you find this video helpful, subscribe to my channel and don't forget to hit the like button. Thank you so much.